will begin chapter 9. We do not have time to burn, and as much as I love you, I'm not going to just stare at you all period. Nay?
Can we do some of the ones that's like A on like the beginning, the first page?
You mean of the review packet?
Or, yeah, like A plus 2B, or find C minus B, or something like that.
Okay, well, which one do you want to do?
C minus B.
All right, C minus B. Well, guess what? Can we even do C minus B? We're on the first page of the review. Can we even do C minus B?
No.
No, because the rule for add and subtract is they have to be the same size, right? And they're not. So that's an impossible problem. Now, is 1 possible? Can we do A plus 2B?
Yeah.
Yes, we can. That one we can do because, again, to do add and subtract, you have to have the same size, and A and B are the same size. So, we'll just take A and add 2B. So, 1, negative 1, 2, 3, 4, 0. Plus, now I'm going to do 2 times B. So 2 times B is going to be 2, 2, 2. 4, negative 2, 10. Because when we take 2 times a matrix, that just means multiply everything in it by 2. Now, how do we add? Oh my gosh. How do we add? We just add the same spots, right? We call it adding corresponding entries. So 1 and 2, put a 3 right here. Negative 1 and 2, put a 1 here, and 2 and 2, put a 4 here. 3 and 4, 4 and negative 2, 0 and 10. There it is, A plus 2B.
So for addition and subtraction, they have to be the same dimension.
Yep. Yep.
We do number 5.
On that same page?
Yeah.
That's C times A. Before I get too far, can I even do C times A? What are the dimensions of C? 2 by 2. What are the dimensions of A? Okay, so I can do that one, right? That one is multipliable. So C and A. And I'm going to multiply these. And I know when I multiply them, I'm going to get another 2 by 3. Because the inside dimensions have to match, and the outside dimensions give me the size of the answer. When I multiply matrices, I do it row by column. So first row times first column will give me the entry in the first row, first column. So I write down the first row, and then I write down the first column, matching up the first number with the first number and the second number with the second number. Multiply each pair and add, so it looks like that's going to be a negative 2. And then when I do this one, same thing, only it's first row, second column. So that's going to be a negative 5. Go ahead and fill in the rest. Tell me what you get, and we'll talk about any entry that we don't agree on. So, Sam?
Yeah.
Yeah. We want to get a good grade so we can keep our A.
That's right.
Wouldn't it be amazing not to have to take the exam?
Oh, it's too late for me for that.
Okay, well, then let's get some cushion in case we don't do well on the exam.
That's my plan.
I need some brave soul to share some answers with me. What you got here? 2? Number 2? Do I have some consensus there? All right, what about here? What? 23? Do I have consensus there? How about here? 26? And here? Anybody not get one of those and want to ask about one of those particular numbers? All right, who else? What else do we have to ask about?
What is number 10 on page 8?
Page 8. Is that the one on the back of 7? Yep, I think I can get that. Let's see. We're taking some medicine here, some vitamins. So I need to fill in my chart. All right, so I've got A, B, and C are my vitamins, and I've got costs down here, and I have brand X, brand Y, and the daily need. All right, so here we go. Let's fill in the chart. Every day, Ted needs 4 milligrams of A, 11 of B, and 100 of C. He can get it from either one of his drugs. Brand X is 6 cents a pill. Brand Y is 8 cents a pill. Brand X supplies 2 A's, 3 B's, and 25 C's. And Y does 1/4 50. So there it is. There's the chart. Everybody good with that? Okay. So what am I doing here? I am trying to find the minimum daily need most economically. What does most economically mean? Cheapest, right? So we want to minimize our cost. And our cost is 6x plus 8y. Now that's in cents. That's 6 cents and 8 cents. So if you would rather do 0.06 and 0.08, you can. But that's what we're trying to do. We're trying to minimize our cost. All right, so what are my constraints? What do I know here? What does that tell me?
2x plus y equals 4.
Well, 2x plus y has to be greater than or equal to 4 because we need at least 4, whatever the unit is of this stuff. So however much vitamin A I'm taking, I gotta get 4 or more to stay healthy. All right, what is the equation for B?
Plus 4y is greater than or equal to.
Uh-huh. And then we got a C. And then we also have our 2 that we always have. X and Y are both positive. So now I'm going to, I think I can just use 1 as my scale. So I think I will. All right, so my first equation, which I'll do in red, remember you can do colored pencils or markers or highlighters or something if it helps you, but you don't have to. If I cover up Y, it looks like X is 2. If I cover up X, it looks like Y is 4. Everybody still with me? I'm trying to hurry so I get this done. Where's that shaded? Out. All of this is shaded, right? Everything but the triangle. Okay? Now I'm going to do this one. Don't panic, you're going to have some fractions here, but it's not the end of the world. We divide by 4, we get 11 thirds. which is 3 point something, isn't it? And if I cover up X, I get 11/4, which is 2 point something. I'm gonna connect those, and where is that shaded? Out. So now I've got everything in this area right here shaded. I'm gonna throw one more in there on top of that. Cover up Y, we get X is 4. And cover up X, we get Y is 2. I didn't do a very good job with that line. And that one is also shaded above. So now it's clear that the corners of my shading are right here. I am shading everything above this. All right, so my points are 0, 4 and 4, 0. And then I've got these two that I'm not sure about. How do I find those 2 points?
Elimination or substitution.
Elimination or substitution, this is where your colors come in handy, because that point is the intersection of red and purple. So red and purple. And you gotta solve that system doing whatever you want. Substitution, elimination, Kramer's rule, inverse method, and that will give you that point right there. This one is the intersection of purple and green. Purple and green are coming together at that point right there. So I'm going to do whatever I do, substitution or whatever, and get that point. Now, when I get those 2 points figured out by doing substitution or elimination, they're going to be ordered pairs. Then what am I going to do? Take all 4 of those points, the 2 I already know and the 2 I have yet to find, come over here and plug them in here. So like that one, 0, 4, that represents 32 cents. So if that's the drugs he chooses to take, it's going to cost him 32 cents a day. And you're going to do that for this point, and this point. And then be careful. Sometimes we want the biggest number, but this time we want the smallest one. So whichever one of these points yields the smallest answer, that's what we want to tell him to do. So if that's the smallest, then we're going to tell him, don't take any X's and take 4 Y's.